So now in this video, we're going to take another look at the relationship between voltage, current, and resistance. Of course, this is Ohm's law. And so the reason why I'm making this video is because current is kind of a tricky topic. It's not as easy to measure as voltage, and even resistance in a circuit. It's not terribly easy to measure, but resistors have values on them once you learn the color code, and it's not too hard. Plus you can look up the color code. So in any case, zooming back for this video, what we're going to do, let's say we want a particular current through the circuit, and it's really easy to adjust the voltage, which it is. I have a power supply. It's not really friendly for taking video of, so I don't show it much, but I can just turn a dial and set the voltage. So what we're going to do, we're going to look at the voltage across the resistor. So right now the power supply is off. I'm going to turn it on. It's set to 0 volts. And also a nice thing about this power supply, you can set the current to a maximum current. So it's probably around like 500 milliamps or something. So I don't have to worry about frying the meter if I accidentally mismeasure a number of things. But in any case, it's set to 0 volts. That's the main takeaway. So we want a specific voltage, or a specific current, I mean, through the LED for whatever reason. We know that we have a 1 kilo ohm resistor here, so you can see the LED lighting up. If I set the power supply to 1 volt, because the current that is flowing through everything has to flow through this 1 kilo ohm resistor, we know that there's 1 volt across the resistor. 1 kilo ohm, that will mean there's 1 milliamp of current flowing through the resistor, which is also flowing through the LED. So that's not the voltage I set the power supply to. I set the power supply to 2.7 volts, and that's what it says on both the meter and on the display of my power supply. That's because the LED blocks, in this case, 1.7 volts. So you're going to see when the LED gets brighter, it blocks even more voltage. So now it's a 1.8. It's only blocking 0.1 volts more, but the resistor has a lot more voltage across it now. It's not 1 volt across it now, it's 6 volts. So we know that about a little less than 7 milliamps of current is flowing through the resistor right now. But that's up. Let's go back down. The main thing is we get 1 volt across the resistor. The voltage is going to hold about steady across the LED. And I'm measuring the wrong thing. There we go. Let's go to the resistor and get to 1 volt. So I goofed there. I was measuring the voltage across the two of them. But in any case, the voltage is going to hold steady across the LED for the most part. It changes a little bit. Somewhere, for this particular one, somewhere between 1.6 volts at very low current and 2.2 volts at very high current. Whereas the voltage for current change is going to change drastically across the resistor. So we got 1 volt. Again, it's a 1 kilo ohm resistor. Let's yank this out and measure current. So as I said, measuring current's a little more annoying. These jumpers, they pop in and out of the board really easy, and a lot easier than these low ones, but these low ones don't block the components, so that's mostly what I use. But in any case, you don't usually measure current. As I said, if you know the value of the resistor, you can just get the voltage across it. So there we have it, 1 milliamp of current. That's what's flowing through the meter. The meter is the jumper now. It should not be affecting the current at all, really. And then the resistor has that voltage, as we saw, across it, which is the power supply voltage minus the voltage drop of the LED. But it has 1 volt across it, 1000 ohms of resistance, and that gives us 1 milliamp of current. So now I can yank this out. As I said, more current's going to flow, so the LED is going to block a little bit more voltage, but for the most part it's about the same amount of voltage. And so I'm going to put a 100 ohm resistor. It has 1/10 of the resistance, so we will see that we end up with 10 times the current. So not quite as much. That's because the LED is blocking a little more voltage, but it's close to 10 volts. So at this lower level, the LED change in voltage makes more of an impact. So let us try to get the LED to 20 milliamps of current. So we're going to make the connection there, and go back to measuring voltage right there. And it's very important to get the meter off of measuring current as soon as possible, because if we would have went across here, the only thing limiting current would have been the LED. And I have the bench power supply though set to limit current, probably about 500 milliamps, so I wouldn't have damaged the meter, but not all power supplies limit the current. So as you can see, there was still that 8 there, and before I turned it up, this is about what it was. So again, we want 20 milliamps, the most that this LED should have passing through it. It's really simple here. We just measure across the voltage across the resistor until we get to 2 volts across it, because it's a 100 ohm resistor now. So we have 10 milliamps of current for every volt across a 100 ohm resistor. And we measure across the LED. There you can see it's blocking a little bit more voltage, but really not that much. It was 1.7 with about half the current going through it. So it went up about 0.1 volts that is blocking. So it takes that voltage from the power supply away from the resistor. But as you can see, it doesn't make a huge impact. So normally you can just make a close estimate. You don't have to be exact. But in any case, there you can see that we got that. So we didn't measure the current yet. Let's yank that out. As I said, this was set up to give us 20 milliamps of current. And so this is the first time I'm measuring it since we made that adjustment, and we should see it's pretty much spot on 20 milliamps of current. Slightly less for some reason. Looks like as the components warm up, a little bit more current's even flowing through. So we probably will hit 20 milliamps once things warm up again. But again, components make slight changes and stuff. Normally it doesn't affect the circuit at all. Exact values don't really matter, but you kind of want to get close, and quick estimates and stuff are really effective, as you can see here. But the main takeaway is with Ohm's law. Once you know Ohm's law, then you don't have to measure everything. As I said, current's usually a pain to measure. We have to put it there. We have a risk of measuring too much current. So especially if you have a 100, a 1000, or any other resistance that starts with 1 and a number of zeros, the math is pretty easy. But as long as you know the resistor value, if you need to know the current going through it, you can just look at the voltage across it and then divide that voltage by the resistance. So this is 2 volts divided by 100, which gives us 20 milliamps. So 0.002 amps, and no, 0.02 amps, I mean. And now here's the 1 kilo ohm resistor, and this one will give us about 0.002 amps, which is 2 milliamps. But again, the LED is not going to block quite as much voltage, so it is slightly higher. So in any case, these are good relationships to understand. You'll understand a lot of other circuits easier once you understand this relationship. And also I have a trim pot down here. So let's go down to here. And I'm going to move this jumper really quick over to there. And let's turn the LED this way. So the cathode is up 1 row, anode down 1 row. And we have the trim pot. So I'm going to set the bench power supply to 10 volts. Just set it to 10. This is a 1 kilo ohm trim pot, but again, it's going to add some impedance, some resistance to the circuit, so it kind of makes things more confusing. But we're just interested in the current going through the load for whatever reason in this video, and so that is the 1 kilo ohm resistor, and the LED is not on because it's turned towards the negative rail. Let us get the screwdriver here and turn it. We can measure the voltage while we turn it right there, so 0 volts, and we turn it up. The LED won't light until we get about 1.6 volts. So this is the voltage across the resistor. I have the probes backwards. That's why we had a negative voltage, but that is no problem. It's kind of odd because usually I work positive up and then negative down. Now I have more positive going up, more negative. So that's another thing. So in any case, again, we will go to 1 volt, and the LED is not very bright. I couldn't remember which resistor I used, so it's pretty obvious. It's the 1 kilo ohm resistor. About 1 milliamp of current is flowing through there. I can yank this quick, and we'll have about 10 milliamps of current going through this resistor. Again, the trim pot is adding some resistance, and so that may throw it off a little bit, but it will be about 10 milliamps of current. You can see that it is brighter. So I'm going to leave a little gap now between the resistor and the LED, and we can use that to measure current. As I said, it should be about 10 milliamps. So that was set with a voltage divider. The bench power supply is 10 volts, and so the trim pot is reducing the voltage, and there you can see about 3 milliamps of current for that one. And oops, I didn't need to remove the resistor. So that's actually the one we set it to. So this one's going to be more accurate. There you can see 1 milliamp of current. So it did throw us off for the other resistor. I should have measured the voltage across the 100 ohm. Let's do that one again. And so yeah, the trim pot threw it off a bit. I was going by a multiple, but that was a bad idea. A multiple of the other resistor that we tested. So we'll probably see about 3 volts across here. And yeah, that's what we got. So we have to, we can't just swap out a resistor in this case, but with a direct connection to the power supply voltage, we could. So there we go. Now we go up to 1 volt across the resistor, and since it is a 100 ohm resistor, so now it's 1.1. We'll know we have about 1.1 milliamps of current when we go through the whole circuit. So there we go. Now let's measure the current. Should be 10 milliamps of current, or 11, pretty much spot on right there. So in any case, these are great experiments to get a better feel for what's going on. Also, you saw I made some mistakes. It was pretty easy for me to start figuring out where I went wrong. I just kind of made quick assumptions, and I was off a bit, but I was able to figure out what it was pretty quickly just from experimenting like this a lot before. So that helps a lot when you're trying to troubleshoot what's wrong with circuits. Once you know the electrical property of components, you can tell what that voltage reading is giving you. And one of that is how much current is going through it. As I said, this LED at very low currents, about 1.6 volts that it blocks, and once you get to about 20 milliamps of current, I think it's like 2.1 or so volts or something like that, plus different colors have different voltages and whatnot, different batches of LEDs. And so I got some red LEDs that will block a little more voltage at a certain current and a little less voltage at a certain current. So that's all good stuff to measure, give you a better idea how your components act electrically, and just get better at building stuff in electronics in general. So hope you enjoyed the video. Thanks for watching. I will see you in the next one.